rhizosphere. You got it? This is research. I don't want to discuss this thing for the PhD first year guys. Now look, this is the Z-axis. So 7.6. This is a characteristic spot. 1:1. So if you are very observant, you can calculate also. Oxygen is having 1.4. Then silica is having 0.39, and this oxygen or hydroxyl will be once again 1.4, and then alumina 0.57, then once again oxygen, and then water molecule. So if you sum up all the radius, you will land up to nearly this portion. Okay? So this is what we call 1:1 clay. Am I clear? One layer of silica tetrahedron sheet is tagged with one layer of alumina octahedral sheet, and this is called 1:1 layer silicate. And the name of this 1:1 layer silicate is kaolinite. Kaolinite. So kaolinite is 1:1 layer silicate. So the entire structure of kaolinite is this. Got me? Fine, fine. So ऐसा 3 वैलेंसी नहीं है, ये सब आधा 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 ये फिर स्टैकिंग होगा और एक लेयर के साथ। तुम लोगों को नेसोसिलिकेट, फ्लोरोसिलिकेट, टेट्रोसिलिकेट जब हम जोड़े थे तब ऐसे बीच में से करके एक बार दिखाए थे ना कि ये आधा आधा एक। now you come up ऐसा सिंपली नहीं सोचो, कार्बन बॉन्डेड with carbon and hydrogen हाइड्रोजन ये हो गया, मीथी प्रो हो गया भाई, क्लास 7 से पढ़ के आया ना। Look, this is what is there in the nature. Okay, so this is the smallest unit I have taken. I said this will be a continuous link. This means it is not, it is there. If you go on doing this, it will be like. I have given only a snapshot of the smallest unit of that one. ठीक है? एक दो बार इसको ध्यान से, you must consult. That is why I said you must consult soil chemistry by Beer. So you consult that book. Even ISSS also you can have a look on that book also. So the let me draw the next one. This is the basic. Now you got this is what then? This is 1:1 dioctahedral. This is 1:1 dioctahedral layer silicate. If I wish to draw a 1:1 trioctahedral layer silicate, then I should do what? This should be this. There should not be any gap. Okay? Now look. You join this, you join this, 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 this. Now what is this? 1:1 trioctahedral. Clear? Clear? Once again, look the charge balancing. Now remember that. Had all this being the aluminium, then it would have been 6. Then positive charge. Now come to the mechanism. Already you have gone through acid soil. Acid soil is what? Acid soil is what? pH is less than 7. Acid soil में what should be the dominating cation? Only H plus? Well, you must have H plus की जो contribution है उससे कोई number magnitude में number of times contribution 3 times more contribution is by aluminium. Let me see. Aluminium 3 plus hydrogen ion, that means what is there? If it reacts with water, what will happen? First, say, what are the products? Like this, that means every step, this step, so one step, one hydrogen, second step, 2 hydrogen, this step, this step 3 hydrogen. That means it would have been a grossly acidic soil. If aluminum is there, 1 molecule of aluminum will make 3 times more acidic than 1 molecule of hydrogen. Okay? So more acidity if aluminum is there, right? So, okay, mind that. Had it been aluminum, I showed it would have been very acidic. Very acidic means pH may be 2, 3 in this range, mein. Okay? Coming to the practical point of view. So this would have been. Now what happens in nature? This generally, aluminium could not be there. Only 10 to 15% substitution is possible, but in a long chain, it will be not only aluminium, it will be, how it will be balancing? Say, like out of 6, aluminum, magnesium, iron, all milake 6. Once again, when this will be trioctahedral, the silica, 4 silica will not be there. It will be silica and aluminum together. Will be a portion of this will be poured. Try to follow me. This is not a small unit I am talking. Say, if I say, and then the structure will be X, say 0.06. That means I will give you the note, it will be written, you will be knowing that. 0.06, that means out of 60 silica layer, maybe 6 will be substituted, 10%. Right? Similarly, here it will not, all the molecules will not be aluminum. It will be a part magnesium, a part iron. Most of the cases, generally out of 6, it is 3.8, it is 2.1, this is 0.9. That means like if you take 100 of this chain, only 9 will be aluminum, 38 will be magnesium, and 21 will be like that, in that proportion. Got me? If it is 60 molecules, then 38, 21 and 9. Am I clear? मैं क्या बोलना चाह रहा हूँ? आप ही लोग ने पूछे, इसलिए मैं अंदर घुसा. नहीं तो, okay. So you got, it is this way the charge distribution. Am I clear? Am I clear? Okay. Now both the dioctahedral and trioctahedral layer you got. So this is once again, and most of the cases when trioctahedral, this kind of layer, we call it charged brucite layer. That means all the 6 molecules is being substituted by magnesium. 6 molecules is being substituted by magnesium. That means none aluminum will be there. All molecules will be magnesium. If it is there, then we call it brucite layer, charged brucite layer, which that is not required. Charged brucite layer, and that is a different kind of mineral group which we call 2:1:1. that one layer will be charged brucite. You don't need to understand all this, but you need to know what is called 1:1, what is called 2:1, and because say 2:1 is having more cation exchange capacity, more surface area, more nutrient absorbing capacity, more nutrient replacement capacity, like that. And the properties of the soil, like 1:1, oxysoil, mostly red color soil. Why red color? Because more of the iron. And where from this iron is, majority of the cases, either it will be magnesium or iron. Like here I said 2:1, if you go the red and laterite soil, if it is a red one, you will be getting vice versa. It will be 3.6 and it will be 2.4, like this. Magnesium, so it will be less of red. Okay, so that compression is there. That is why it is many a time. Have you visited any place which is having red soil? Have you ever? You will see it is so hard. It is just like a pellet of iron. Have you seen? I mean, so this is what? This is the mineral composition inside the clay structure. Okay. Now, so this is. Once again, you said the chart, I have shown you the charge distribution, and if it is being substituted by aluminium, I showed it will be the positive charge, and positive charge means more of the aluminium will be dissociated to hydrogen, and then more of the acid, and so it will be the pH will be to that range. Remember that. This is one part which I wish to draw another curve where you will be getting many things clear. Okay, this is one. Now,